Salutations. This is Bant Wizard for Hire. We're going to be going over some math today. Alright, so this is Algebra 1, and we're going to be learning some arithmetic properties. Just some basic arithmetic properties, but everyone knows the basics. The fundamentals are fundamental. They're important. So the first one that we're going to be learning today is called the associative property. Associative property, if I can spell. Associative property. All right, so if we have three numbers, a times b times c, but b and c are in parentheses like this, basically what we can do is we can kind of shift the parentheses to make this a times b in parentheses times c. And this kind of works for any sort of orderings with the a, the b, and the c here. And I prepared a couple examples to make it a little more easier because maybe math is a little bit difficult for you and you are not really getting this with with letters. So 3 times 2 times 4, and the 4 and the 2 are in parentheses. So to solve this, we would do 3, because we don't touch the 3 yet, we just do it inside the parentheses. That's 3 times 8. And that equals 24. Cool. Awesome. So now if we were to look at this example right here, we do the 3 times 2 first, because that's in parentheses. Everyone remembers PEMDAS. So that's 6 times 4. And what is 6 times 4? 24. Perfect. So therefore, since these equal each other, we can say that 3 times 2 times 4, where the 2 and the 4 are in parentheses, that equals 3 times 2 in parentheses times 4. Lovely, beautiful, awesome. Let's move on to this next example. So this is the same thing, just with different numbers. So we have 15, so we have 15 times 2 times 10, where the 2 and the 10 are in the parentheses. So we do that first. 15 times 20. And actually, let's do this. So let's just do this a step at a time. So 15 times 2 on this other example down here. 15 times 2 is equal to 30. And that's in parentheses times 10. And then 30 times 10, that's easy to do. That's 300. 15 times 20, that is also 300. I'm not gonna lie, I had to pull up a calculator for that. And would you look at that? They equal each other. Therefore, we can say that 15 times 2 times 10 is equal to 15 times 2 times 10. Hooray, big happy smiley face. And yeah, that's the associative property. And the associative property also works with variables. So let's say here we have 2 times 3 times x, where 3 times x are in parentheses. And since this is algebra, x is a variable. It represents a number that we do not know as of right now. So we do what's inside the parentheses first. So it's 2 times 3x, or 3 times x. And then what we do is we multiply the 2 by the 3, which equals 6x. Cool. And then let's see, over here on this example, we have 2 times 3, in parentheses, times x. So to start this off, we do what's inside the parentheses, which is 2 times 3, which is 6, times x, which is just 6x, because in this context, we don't know what x is, so we can't do anything more. So we're done with those. And by the associative property, we have 6x equals 6x, or basically, if we bring it back to these two, we have 2 times 3 times x is equal to 2 times 3 times x. Lovely. Now going back to this example, we can kind of reorder some things too, which will be explained in the next part of the video. But let's see, what do we got here? We have we have 4 times x times 3, where x times 3 is in parentheses. So let's see, we don't touch the 4, and we do x times 3, so that's x times 3, or we can reorder that as, we can reorder that as 3 times x, and then that is then equal to 12x, because we multiply the 4 by the 3, and then the x just kind of tags along for the adventure. And yeah, we got 12x. So then what do we got for this other one down here? We have 4 times x in the parentheses, 4 times x, and then times 3 is outside of the parentheses. So what's 4 times x? It's just 4x, and then it's times 3 on the outside, which is just equal to 12x, because 3 times 4 is equal to 12, and we don't know what x is, so that's kind of all that we got. And look at that, we got 12x, which we can bring it back to the original example, which is 4 times x times 3 is equal to 4 times x times 3. Perfect. And the next property that we're going to be explaining is called the commutative property. And this is a relatively easy property, but there's 2 different sub properties, I guess, within this one. So the first one that we're going to be discussing is with addition. So basically what the commutative property states is, if we have 2 numbers, a plus b, and we're summing them, we're saying that that is equal to b plus a, which makes sense intuitively. So if you have 2 numbers added together, it doesn't matter what order they're in. So let's look at some examples. And like I said earlier, this is really simple, but it's really important if you want to get good at math in the future. So here we have 4 plus 8, and then, so what's 4 plus 8? It's 12. And if we just kind of swap them around, we have 8 plus 4. That's still 12. It doesn't change the value. It doesn't change the sum. And look at that, 12 equals 12. So we can say that 4 plus 8 is equal to 8 plus 4. Coolio. And then looking at just another example to help solidify this into our memory, we have 12 plus 1, which is obviously 13. And then here we have 1 plus 12, which is also equal to 13. Just like in the previous example, we can then say that 12 plus 1 is equal to 1 plus 12. Just like that, we're done. Well, with this part of the commutative property. Okay, and the second part of the commutative property we're going to be working with is in reference to multiplication. So what this says is that if we have 2 numbers, a times b, and we're multiplying them, a times b, we can say that that equals b times a. So let's look at some examples. So this first one, we have 2 times 3, which is 6. And then we have 3 times 2, which is also 6. So therefore, they equal each other. So we can definitely say that 2 times 3 is equal to 3 times 2. And we're done with that. And then looking at this next example, we have 4 times 5, which we know that that is equal to 20. And then we have 5 times 4, which is also equal to 20. I sound like a broken record, but, it's always good to do repetition when trying to learn math. So since 20 equals 20, we can say that 4 times 5 is equal to 5 times 4. And we are done. And the final arithmetic property that we'll be discussing today is called the distributive property. Distributive property. And what the distributive property says is that if we have 3 numbers, a, b, and c, right? If we have the sum b plus c in parentheses, and a is being multiplied by that on the outside of the parentheses, we can say that the a gets multiplied by the b plus the a getting multiplied by c. So what that looks like is a times b plus a times c. And like the previous examples, let's see some examples with some numbers. So we have 2 times 3 plus 4. So now what is 2 times 3 plus 4? Well, we have 2 on the outside of the parentheses. 3 plus 4 is 7. So therefore, 2 times 7, which is equal to 14. Cool. And then the distributive property, if we take 2 to be equal to a, 3 to be equal to b, 4 equal to b, c, the distributive property states is that we can do this to it. 2 times 3 plus 2 times 4. So 2 times 3 is equal to 6, and then plus 2 times 4, which is equal to 8. 6 plus 8 is 14. Look at that. 14 equals 14, so therefore we can do 2 times 3 plus 4, where the 3 plus 4 is in the parentheses, and set that equal to 2 times 3 plus 2 times 4, and have that be correct. Lovely. Let's look at one more example where we have 8 times 1 plus 3, where the 1 and the 3 are in parentheses. Well, 1 plus 3 is equal to 4. In like the earlier examples, we don't touch the 8. Then 8 times 4 is equal to 32. Cool. And then the distributive property says that we can kind of split that up a little bit to get 8 times 1, which is 8, plus 8 times 3, which is 24. And then 24 plus 8 is equal to 32. And again, since 32 equals 32, we can state that 8 times 1 plus 3 is equal to 8 times 1 plus 8 times 3. Cool. So we can kind of see how the distributive property almost sort of combines the associative property and the commutative property all in one, and then kind of just, use it.